So let's go to page 7 in your booklets. I believe we're in 7. And so I want to remind you before I continue, right? Make sure you watch the lesson because I show you how to use your calculators to manipulate data, right? To kind of arrange it, sort it, do all kinds of stuff, okay? And why are we going to do that? Because to be honest, finding the average just like that for one set of data means very little. Quite often, when you look at averages and standard deviations, we use it to compare data, to compare countries, to compare cities, to compare, right, one versus the other. And so that is what's going to be heavy in this unit. So when I asked you to enter this into L1 and L2, we can figure out, right, the mean, the median, standard deviation, range, and the mode for both sets of data. This I did cover in the video, okay? One thing I want to make sure that you always look at, hey, how many numbers did I type in? Because if you miss one, if this is 29, okay, that means that you've missed one. Did I assign this one or did I go over it in the video? I'm not sure. I feel like I went over it in the video, but regardless, you still have a chance to do that. So when both of them had 30, okay, and we looked at the mean. Hey, look at the mean. It's about the same. The median is exactly the same, but standard deviation, that's when we had some differences here. So remember, I know I'm repeating myself. I know that, okay? But a high standard deviation tells me that data is spread out more so than the lower one, right? If the standard deviation is lower, that means that your data is more clustered around the mean, okay? Because remember, standard deviation by definition is the average distance of every single data point to the mean, okay? The average distance. So obviously there's a greater average distance here from every point to the mean compared to this one. Okay. I know it's some of these terms you're going to be like somewhat frustrated with, but I think as I repeat myself and I explain it different ways, you will start to wrap your head around it. In fact, some of you are going to go to university if you choose to do so, and you're going to take a course called statistics. Your field might require you a lot of medical fields. Like if you want to go into medicine or nursing or anything like that, they want you to be able to interpret data. They don't want you to be fooled by data because someone can take data, do a whole bunch of stuff to it, and present it to you. Be like, hey, see, this is what it's saying. And you're like, wait a minute, are you looking at the full picture? For example, standard deviation. Are you considering your standard deviation? If you're not even considering it, then this might be very deceiving. Look at this. Battery A and B, or X and Y, they have about the same average, lifespan. What's the big deal? But then you dig a little further, it's like, wait a minute, Brent, X is all over the place, right? It's all over the place. That's not necessarily very good. Okay. I don't know if I looked at the Amazon, if I talked about the Amazon reviews, if you've got like 1 star, 5 star, 2 stars, 5 stars, 1 star, like if it's like all over the place on either extreme, that's not a good sign. You might actually end up regretting your purchase, okay? All right. So what I did with this data, I also made a line graph, a line plot. Now, hold on. I'm going to pause here for a bit. I would still strongly recommend you trying pages 6 to 8, okay? The battery question, the one I just talked about. I'm making a line plot. I have the key posted, okay? What I want you to do, and at first this is a lot of clicking, right? A lot of figuring stuff out. We're going to fill in this table based on 10 games, right? 10 games we've tracked data for the different players. I don't know what game. I'm guessing, I don't know, it could be basketball, we don't know. But we're gonna, for every single player, determine the range, the mean, and the standard deviation. Okay, and we're gonna consider this points. These are points. Okay, so 36 points, 41 points, the second game, and so forth. So I want you to do that for every single player. And here's a trick. I don't know if I talked about this in on the video. I have a whole bunch of stuff here I need to erase. Okay. So I want you to place Anna's scores into L1. Okay. And then L2 for the other players and so forth. Okay, so you go L1, L2, L3, L4. I don't want you to erase those data points. I want every single player in a different L, a different column. And then we're going to go one variable statistics, and we're going to find the range, the mean, and the standard deviation. Just in case you're drawing a blank. And I do want you to feel free to ask me questions if you watch the video and you're still wondering about, you know, certain features that you're not quite understanding. Come and see me. So I'm entering Anna's scores and I check that there's 10, right? L1 10, that's the last entry. Then you're going to go stat, calc, and then we go one variable stats, one variable statistics. And you tell it, by going second one, you tell it to go and grab all the values in L1 and perform your calculations. So here it is. The first number is your mean, like X bar. You can write it in your notes. X bar is my mean, and write it down. So that's 36.7. Decimals are quite all right, okay? Because we're using them to compare. And then my standard deviation is this one right here. This number, 5.88. And then the range, did I show you how to find the range? You go max, subtract the min. That's how you find the range. So the min is right there. It shows it right there. So that's 27. And the max, if you scroll down, is 45. So watch this. I would strongly suggest you write these down because sometimes it's helpful for later analyzing your data point. Because like, hey, as high as 45, right? Anna scored 45 at one point, but then 27 was the lowest score ever. So I will go 45 minus 27, right? So that would be 18. So a range of 18 between the highest and the lowest score. I want you to do the same thing for every single player and fill this in first and foremost, okay? I'm going to walk around just to see if you need help before I, so compare, see if you got everything correct. I'm going to get going here. Right, first thing, when you look at data, the mean, sure, it's important. We can tell by just looking at the mean that on average, Anna's the one that's scoring the highest, correct? Just like that. If we just look at the mean, it's like, oh yeah, Anna's overall doing best, right? But let's look at some other things, and that's where standard deviation and range come in. Look at, for example, Morgan. Morgan has a range of 29 and also the highest standard deviation. I hope that would make sense to you that that's the case. Because if you have a big range, so that means that Morgan goes from low to high, right? This is the low, this is the high. And this is the range. Okay, the difference between that is what we call the range. So Morgan has the highest range and therefore also the highest standard deviation. Okay, and look at who has the lowest range here. Page has a range of only 2, right? Between the highest and the lowest score, there's only a difference of 2, has the lowest standard deviation as well. So for Page, this is low, this is high. Okay. So small range, small standard deviation. So a couple things to just keep in mind. Anna has the highest average, but look at the range and the standard deviation. Her standard deviation is quite high. Quite high. So that means that you're not as consistent. Okay. You're not as consistent. If you were to put the scores on the number line, they would be a little bit more spread out than if you look at Page's scores. Okay. So let's answer, and this is the meat and potatoes of today's lesson, right? I'm going to try to keep the table on there. We'll see. Which player would be considered most consistent? Okay, most consistent. Which player is least consistent? Explain how you would know specifically. So I would say that Page is the most consistent player. Sorry. We know this because she has the lowest standard deviation. If you're okay with just going SD, okay, then do it. You can also say standard deviation sigma, lowercase sigma, right? It's also known as standard deviation. Okay. Her range is also the lowest. Okay, so that's actually what we expect. Low range, low standard deviation. Okay. Least consistent would be least consistent. Who has the highest standard deviation? Morgan, right? So Morgan, oops, I get too excited here. It's only statistics. Okay. Morgan is the least consistent player, comma, since her standard deviation is the highest, right? So is the range of her scores. Okay, it could be the range of someone's income, right, and so forth. Identify the player with the greatest average score. Would you consider her the best player? Explain. Um, um, the player with the highest average or mean, okay, is Anna. Would you consider Anna the best player? Based on the mean, yes, correct? Who is really close to Anna's score but has a smaller range? Got Patrice, right? She's got just a little lower average, but look, only a range of 5, a standard deviation of 1.5. I would argue that Patrice may be better overall, more consistent, may have to work a little bit harder to improve that score, but is most consistent. Because as a player, as any athlete, you would want to be consistent. If you're like bombing it one day and the next day you're like awesome, like you're getting every hoop in, right? And then the next day you're bombing it, you're not as consistent. You could hurt the team overall in the long run, right? So the player with the highest average is Anna. Uh, she would not be considered the best player since her standard deviation is quite high. So you're going to be like, wait a minute, this is English class? Like, why are we writing like essays? So unfortunately with statistics, it is. It is math, but it's also interpreting. Okay. Patrice has a mean that is very close to Anna's, yet she has a lower standard deviation. Which player has the potential to score at least the least amount of points on any given game? Which player has the potential to score the most points? Least ever, which one would it be? That's where I kind of broke my own rule. I told you to show the min and the max as you were doing the math here. Can somebody help me out? Because I probably won't see it. Oh, hold on. Anybody know the lowest score? Is it, I see a 19 here. Is there something lower than 19? 19 is the lowest, right? So Morgan, since her lowest score was 19 and the highest, I see 44, 45 for Anna. Is there something higher than 4? Oh, there's 48 for Morgan right here. 48, I'd say Morgan. Morgan as well. Since her highest score was 48. So she scored the highest, but she also scored the lowest. And that's why Morgan's standard deviation is so big. Okay, right? The gap between the highest and the lowest. The higher that gap, the more spread out your data will be. Okay. You were the coach. Which player or players would you choose based on your decision on what happened before? Okay, this is what I'm going to ask you to do. Homework. I need you to practice this, okay? 11 to 12, but don't forget pages 6 to 8. That's the battery question. I need you to know how to do a line plot, okay? So if you didn't do it, the key is still posted from last week, okay? So this is what we did today, 11 to 12, and 6 to 8 is the line plots, right? And if you don't know what I'm talking about, you need to watch the lesson on line plots.